Let's solve this differential equation. My approach is going to be separation of variables if I can, because usually that's the easiest approach. This one's a little tricky, I think. So let's see, I would just rewrite 4 plus x dy dx using that differential notation, which helps me do a little algebra here. And then if I wave the algebra stick, I should get 1 over 4 plus x dx equals, it would be 1 over 7y, I guess. Sorry, I skipped a couple steps there, so I hope that makes sense. You could do a couple more steps of algebra to get there. And then from here I could integrate, right? I've separated my variables and I could integrate. It might help us, and as you do these, you'll recognize these little things. It would be nice if I could solve this right side for y. Sometimes we can do that, sometimes we can't. And if I'm going to solve the right side for y, I don't like that 7, right? So I'd multiply both sides by 7. And then that just puts a constant over here. It complicates the term on the left side, my x function, my function of x, but it doesn't really matter, right? It's gonna look, I think it's gonna look nice when I integrate the right side. Okay, so let's take a look. Now you integrate both sides with respect to those variables, and this would simply be the natural log of y, and this is going to be, you can move this 7 out if you want to do that extra step, and you get the natural log of 4 plus x, right? And the 7 would be out here, and I didn't do u substitution. In Calc 1, we would do u substitution here, or when you first learn it, you might need it. But remember the check. The check would be take the derivative of this, what do you get? So remember, the derivative of the natural log of a function is 1 over that function times the derivative of that function using the chain rule, right? And the derivative of 4 plus x is just 1. Okay. And the 7 just kind of comes along for the ride, right? Constant multiple rule. Okay, good. Now I need a constant. All right, let's solve this differential equation. Find the general solution of the differential equation. So our job is to solve this. We have maybe a couple methods, but so far in our class, I think we just have one really, and that is separation of variables, okay? Which we'd want to try. If we had more methods, we'd want to try that anyway, because typically those are pretty straightforward. That is, I want to get all of one variable on one side, the other variable on the other side. So first we would need to switch up our notation, which should help us. So I can separate this, do your algebra. No, let's save some steps. I think you could see this. You would end up with, I know I'm skipping little steps here for the sake of time. You should end up with this. Should end up with that, okay? And that's a little bit of algebra to get there. And then I have my variables separated. I could integrate here, but I can see, and the more you do these, you'll be able to see this kind of stuff. That in this case, I don't like that 7 being there in the denominator, right? Because I feel like if I just had 1 over y, I might be able to solve for y, and that 7 might get in the way. And so I multiply both sides by 7, and it's up here. Okay, now you might not recognize that right away, but like I said, the more you do, the more you'll realize little tricks like that. It just make your solutions look cleaner. In this case, I think we'll be able to solve for y. Sometimes you can, sometimes you can't. In this case, I should be able to. So let's integrate. Let's do the calculus. That would be, if you want, you can pull that 7 out here. And it just depends on your method or how comfortable you are with integrating. We could call that u and do u substitution. But I think hopefully if you're familiar with the integrals that end up as natural log functions, or the derivative of natural log functions, maybe I should say that if I differentiate the natural log of 4 plus x, I get 1 over 4 plus x times the derivative of 4 plus x, which is just 1. Okay, so you can always check those. And then over here, of course, I would just have the natural log of the absolute value of y. And of course, we need a plus c, right? We learned in Calc 1 to always do plus c because there could be a constant attached to that. Then when you differentiate it, it would go away or it'd be equal to 0. So we can kind of choose what side we want to put on. And I think my goal here is to try and solve that right side for y, which I think should be easy, right? E to the natural log of y is just y. All right, so that'll allow me to give a nice solution, y equals something. All right, doing pretty good. Now, how do I clean this up? Well, I just gave you the hint. If I on the right side, if I said the property goes like this, a to the log base a of x is just equal to x. That's our inverse property, right? So that's what I'm gonna start. I'm gonna make that an exponent. And there's another property. A to the m times a, sorry, I'm going to need that property, I think. But the property I'm thinking of is if a to the x equals a to the y, then what has to be true? X has to be equal to y. Okay. And I'm abbreviating a has to be greater than 0, not equal to 1. But hopefully you remember that's some of that from algebra. So I'm allowed to, I'm going this way, right? I have an equation. I'm just going to make those both sides of the equation the exponents, and I choose my base. So my base is e. And primarily I'm doing that because I got the natural log, right? I'm working with a natural log. So on the right, that's nice. I just get that. On the left, here's another property. A lot of properties, a lot of algebra here. A to the m times a to the n is equal to a to the m plus n. You remember that, like x to the third times x to the second, that's x to the fifth. And that's the property I need here because I have this sum that I want to make a product. So that would look like this: e to the 7 times the natural log of 4 plus x times e to the c. Those are the same thing, right? That's if I went this way, I'd be going this way, right? That is two bases, each with an exponent. I would add them together. All right, so that's gone now. Right now it's a product. All right, good. Making some progress here. Like I said, the calculus is done, right? The calculus, let's quick review. Algebra, one step of calculus here, and now we're just doing a bunch of algebra to try and make this look nice. This 7, here's another property. It would go something like this. Some constant times a log of any base, let's just use x here, is the same as the log of any base of x to the power of c. And that has something to do, I won't get into that, but that has something to do with the relationship between logs and exponentials. Okay, so we're going to use that, and we're going to go this direction. And in other words, I can take the constant multiple that's multiplied by a log expression and make it the exponent. A very, very useful algebraic property in calculus. Oh, I forgot this. What are we going to do with that? I'm just going to call that C. You can just call it C again. I wouldn't mind. I think technically, since this is a constant, this would most likely be a different constant, so we could call it C1. I wouldn't be too picky about that. It's just there's a constant times this exponential expression. Okay, and now we're doing real good because we can use the property again that we used before. That is, we use this property. E to the natural log of something is just the something. E to the natural log of something is just the something. So I got C1, and then it's E to the natural log of absolute value 4 plus x all to the 7th power equals the absolute value of y. And I'm almost done. I would now say, what would I say? Oh, I just rewrote that, didn't I? Let's actually apply a simplification step. That would just be the natural log of 4 plus x all to the 7th power. Okay, so I got a lot of absolute value bars I've been carrying with me. I don't really need them, right? Because the absolute value of y we could write as plus or minus y. Same thing with this other expression. Sorry, and get that right one of these times. E to the natural log of the absolute value of 4 plus x to the 7th is just 4 plus x to the 7th. Okay, and now what do I do with these absolute value bars? Well, I can just get rid of them, right? Because this would be like plus or minus y. We could think of it like that. Same thing on the left. And because we have this arbitrary value of c that could take on a plus or minus, we can just get rid of those. And it looks real nice. I got the c1, 4 plus x to the 7th equals y. And that's my answer. And I mean, I don't like the C1 thing. Like I said, I'm not picky. We could call. I would probably write my answer like this, and technically, I think I'd have a minor error here because this C here, I'll fix it. I'll call that C1. Okay, and then if you're plugging this into your homework system, most likely it'll tell you to use C as your constant, so you'd want to write it like that. Okay, that's a great problem for the separation of variables that involves logarithms. Like I said, the calculus was pretty straightforward, right? We just did one step of calculus, and then the rest was all algebra. So we have a little algebra exponent and logarithmic review in that one. But that's a nice, concise answer for our solution to the differential equation by separation of variables.